Hi, everyone. I'm Sevgi Erdoğan, a professor at this iSchool, and I started just last January. So I thank Raj and Jeff for building a good foundation for my talk. So I'll talk about how you can put these skills and data science and data analytics knowledge into good use in a city context or urban planning and engineering context, right? So I'm by training an engineer. We typically work with data to do something, to build something, or to come up with solutions. Or we are basically problem solvers. So let's get to it. So what are the problems we are dealing with in this century, right? So let me these are typically known as 21st century's problems or 21st century's challenges. So one of them, we know that urbanization continues and it's growing, and it's almost 82% of the US population lives in cities now. And this is expected to increase even further in next 50 years or so. And world's population is also 50% currently living in cities, and this is expected to increase, I think, 58% by 2050 or so. So what does that mean? Increased population living in cities. You know how the city infrastructures and the resources and services are put a great strain on the resources we have and infrastructure we have, right? We need to make them more efficient and manage them in a better way so that we can handle this increased demand and strain on resources we have. And on top of that, as you know, there is climate crisis we are dealing with, and almost it became like a daily phenomenon, right? We are hearing disasters happening, if not here, in other side of the world, and so on, and increased income inequality. So these are all things we are dealing with. And we live in cities. So major question the engineers or planners ask are, how do we prepare for a sustainable future, right? How do we deal with all these challenges in an uncertain world? We cannot, we can design, plan for everything, but we have driving forces that are not under our control. Economy, politics, technology, even technological development, right? It's kind of led by the industry. Some, for instance, like internet came, transformed everything. Mobile phones, they don't look like so significant, but actually they changed our lives, right? They're allowing all this data and social changes. So question is, how we can live future cities? We can build future cities. So smart cities came as one of the solutions. I would say they are probably not the solution, and technology itself is definitely not going to be the solution itself. But so this diagram I took from the OECD's Smart Cities Performance Measures report. So I kind of liked it. So they use 3 pillars. For smart cities, the first pillar is having the tools and the applications a smart city needs, right? So those are kind of like it needs to be smart, it needs to be connected, smart mobility, jobs, communities, housing and built environment, education, e-government, and you can think of many other applications. But some of them are here, like smart mobility, resilience and disaster response, governance, healthcare, energy efficiency, and you can think about it. Once, these of course require technology and the built environment. We need to build these applications in a city context, right? And then once you have this, stakeholder engagement, right? That's the second pillar. So government, public, and industry need to work hand in hand. And I would add also researchers and academia into this, because they are kind of the binding force among among all these three entities. And the final pillar is, once you have these set, the goal is to have a society, resilient, sustainable, and inclusionary society, inclusive society, where quality of life is high for everyone. So, but how a city can be smart, right? So what do we mean by smart? So you can think of a city as an interconnected systems of systems, right? So at the bottom, we have infrastructure like sewer, water, and all other service infrastructure. And then there is the public realm, like social life activities, entertainment and parks and recreation and so on. And the mobility, that's includes the transportation infrastructure, like roads, bridges, airports, and everything. And these are all kind of like, you can think of them as like networks. And then we have the building infrastructure on top of that. And these are, you can think of these are interconnected physical networks, right? Because roads are on land, they are not disconnected from the infrastructure, water, stormwater collection, for instance, right? They are all connected. Houses are connected to roads or the electric facilities and so on. And then on top, there is a digital layer. We can think of that digital layer as our what makes the city smart, actually. Like we can put a digital layer, an information collection devices and system that binds all these interconnected systems together and makes them communicate. And then how does that happen? So at the core of the smart city, at the core, we have the smart city combined with all these systems connected together with a digital layer. And then data, massive amount of data coming from all kind of sources, right? We have the people walking with cell phones, giving location data or collecting location data. We have social media. We have sensors on our, in some facilities, right? Well, in a smart city, I will get into that shortly. We need to also put information collection infrastructure so that we can collect more data, right? So at the core, data production, data collection. And these data, the massive amount of data are typically collected in real time, not necessarily, but in an ideal smart city context, they need to come continuously streaming in real time. But where do these data go, right? So there is a huge amount of infrastructure storage capacity and facilities needed, technology, let's say, to collect this massive amount of data and store and make use of them or make them available for analysis. So then as data scientists, your role comes in. You use your skills and knowledge to work with data, make sense of this data, right? So you need to be able to access and process this data, which is in smart city context, because it's massive, it's itself a challenge. And applying your knowledge on top of that is also needed. So that we create knowledge insight about cities' functions and how things are going. And then we give insight to the city managers or governance for different type of decision making or service design, all kinds of city-related decisions and functions. So basically, the engine behind smart cities is actually data or big data. So data and big data, when the data is actually not So you can define or think of big data as like data that doesn't fit in an Excel sheet, or you cannot open with traditional software, then you call it big data. Sorry. So what makes big data, what enables big data is computing power and cloud computing. So these things, we were not able to imagine these things like maybe 50 or 60 years ago. But now we think increased capacity, computing capacity and storage capacity and advances in technology makes this possible. And IoT devices, right? So what the intelligence or all this data we need to collect requires technology, Internet of Things, right? So those are sensors, lights, meters that we can place on everywhere in a city you can think of that you need data from. And information communication technologies like 5G, mobile phones, cameras, and so on. You can think of all sorts of information collection methods or technologies. So again, so basically data science in urban context takes maybe called urban informatics. So data analytics or data science, you will see many terms. It's still like not very clear, but when you see urban informatics, it's a different data science applied in the city urban context. So I won't get into details maybe because Jeff already went into, but it's the same principle, right? Data collection that comes from these big data sources, processing that data, but it's big data. So it requires a bit specialized methods, analyzing data for decision making, presenting and communicating those results to decision makers, and having insights and knowledge about problems that cities are dealing with. And so that outcomes goes back to, again, the data collection. So because the actions taken based on the data analysis or results, decisions made, and those are probably applied in the real world, and new data comes in, you evaluate, and then if there is need for change again, based on your analysis. So this is kind of like a continuous process. It doesn't end. So we already talked about big data. I'm not going to go into that, but it's 5 characteristics of big data are volume. They are in a massive amount. Speed with which they come, usually real time, but not necessarily. Sometimes they can be sequential too. And veracity based on reliability or accuracy of the data, right? Because these data are coming from different sources, and like let's say GPS data or location data, right? They are typically not very reliable. So that's another challenge we are, as data scientists, to deal with. Types of data, that's as Raj talked about, it's very important, right? They come from many different sources, and typically they need to be analyzed and brought together. And the relevance value of the data. So I like this definition of Mike Petty, an urban planner and geographer, or some big data. You can read about it. So basically, it's the importance of data that provides massive amount of information on how individuals and urban objects change and interact in space and time. Much of this is unstructured in that order, and its collection is usually imposed, and analysts must either discover this order or impose it from prior conceptions. So basically, this kind of exploration, right? So we don't know what we are dealing with until we analyze. So these are some of the data analytics techniques that enables big data smart city applications function. So for instance, stochastic modeling, like probabilistic models that were like considered traditional, more or less. As we talked about machine learning, the reinforcement techniques, unsupervised learning, supervised learning, these are all necessary for big data analysis. And further than that, advanced learning techniques, and these are enabled by also computing platforms, right, to analyze, to work with big data, cloud computing, edge computing, crowd computing, which is, you can think of it as a form of citizen science. And so these are all the skills and methods as data scientists you harness, and they will come handy, or they will be very, they are needed for urban analytics, basically urban informatics. So I just saw an random article yesterday, like data scientists, cities are watching for you. Like cities are all in an effort to become smarter, and they try to apply even small steps. They may not sound very advanced, but as you will see in some examples, that because it's not only data analytics, but putting the sensors in, collecting the data, storing data, and making them available, making sense of them. These are all cost money, right? These are not simple things to accomplish by a city, especially if there are economic constraints and decision or the governance issues and so on. So these are every step is a good step, we will say, because so potential for urban informatics is, after having able to have this big data at our hand, exploring, understanding, and leveraging novel data sources in four main areas we can think of. One is, as I've talked about, the challenges our cities are facing in this century. Dynamic urban resource management. That's one of the ways that urban data analytics can help. And theoretical insights and knowledge discovery, right? So we have, as each field domain knowledge have their ways of doing things. They have their theories, models, but with the inclusion of these big data sources, those knowledge and models and theories maybe don't apply anymore. Maybe there are new insight or new science coming out of the data, right? Things are different now. So because we were relying on traditionally collected data and limited, right? So things are changing. I'm a transportation engineer and modeler. One of the biggest challenges we are dealing with right now are the models we are working with are not meeting the demands or meeting the needs of current cities or current transportation systems, because there are many new components in the system that our traditional models don't know how to handle or don't know how to represent. So these new insights are important. And urban engagement and civic participation, right? So we talked about, social media, mobile phone apps, and so on. So these are allowing public and to contribute to or be part of the decision-making process and how the city develops, how the city grows, right? So you can have, let's say you are going to have a new development in some area, you can actually ask people what do they think, what kind of development, or a park is going to be built, right? Or a park is going to be created. So you can ask actually people's opinion about where that park should be, how should that be, and so on. So, and the fourth one is management planning and policy analysis, right? So with these enhanced rich data sources, city governance can be much more efficient, and planning and policy decisions can be much more to the point and meet the needs. So there are, despite the challenges, as we talked, there are many cities in the world trying to apply some of these smart city applications. So if you categorize some international outreach, technology and mobility and transportation, these are the major areas those smart cities in the world are focusing on. So if you look at in the US, New York City and San Francisco are ahead. And in the world, I think Singapore is like China is actually has, I think, maybe, I forgot the number, but the most number of smart city applications or smart city initiatives are happening in China. India and other countries are also, other Asian countries are also not far behind. And London is, UK is another one. Europe, in some European countries are also ahead. So I'm gonna give a few examples from here. If you search for like smart city initiatives or applications in one of these cities, you will see really some interesting, cool things. Actually, like Raj, I had some really nice videos, but I didn't think we could show. So I would suggest you go ahead and check some videos. They are really, really interesting, especially Singapore. So Singapore is like the most advanced smart city or nation, actually, because it's a nation. They are. So before going to the world, we can look at our back door. Syracuse, it may be a small or mid-sized city, but it is becoming smart. And there is a nice article, actually, says street smart. The steps are small, as I mentioned, but the dreams are big, let's say. So it's actually, smart city is one of the, selected as one of the 8 cities to watch for in smart cities. And it's a flagship smart city in New York State. And so the target areas are enhancing connectivity and service delivery, as well as lowering the digital divide. So in Syracuse, apparently 40 to 45% of the houses don't have broadband access. So that's a huge amount of divide, I would say. Like, you would not think that, this amount of households don't have access to internet. But city is trying to provide broadband access in libraries and some hotspots and so on. But there is still a way to go. And it has a city-wide 5G wireless. And one of the achievements Syracuse did, part of the Governor Cuomo's initiative to implement 500,000 smart street lights in the state of New York. And Syracuse got its 17,000 LED street lights from this effort. So these LED lights not only save energy and money for the city, but also they enable a smart city, or this, they can function as a sensor to collect information, and they also are smart grid enabled. So basically, they are seen as a city by the city as the backbone of cities' information network, or all these street lights creates kind of like that digital layer I mentioned. That's a small step to build that kind of layer on top of city that communicates information. And for instance, Mayor Welsh mentioned some of the plans that, so with these lights, there is, I think like $3 million were saved in energy, because these smart lights can be dimmed and turned off and or on based on the light, sensing the light, and increasing other sensor-enabled road temperature. For instance, as you know, we get a lot of snow. So if snow and ice removal can be tied to monitoring temperature on the roads and so on, this can also save city energy and time from allocating resources to these services. And yeah, city is planning to increase its sensor network to improve other services. And New York City is also a flagship smart city. There is many more applications, but I picked few of them. So New York has smart indoor lighting, wireless water meters, traffic signal priority for public transportation, responsive traffic management, air quality monitoring, snow flow tracking, real-time gunshot detection, and water quality monitoring, and so on. So few examples, for instance, in the bottom picture, so that's the 24/7 service requests. That's like 311 calls. People can, if you see a pothole or some problem on the road, you can send a text or picture of the problem, pothole, and through your phone with an app. And then city receives that information and sends crews to fix that. Whereas in regular conditions, you would have to call someplace or put a request in a website, and who knows, but this is real time, you send a note. So in the second one, I think smart water meter, just there are sensors on the like water meter at homes, and they track the water usage, or if they go out of the regular pattern, you get a notice. You may have a water leak or something because your water consumption is more than usual. And the second one, the one in the bottom, that's the transit priority. I think, let's say a bus comes to a traffic light, and that sends a signal to the DOT, Department of Transportation. So especially if the bus is late or something, it's not on schedule, that DOT sends a signal to the traffic signal to give priority to the bus. It turns, the lights turn green for bus, and bus can move quickly. So there's this kind of, and the last one, the one on the top, is the gunshot detection. I've heard some other examples of this in other cities. So this is like sensing detecting the gunshot noise. So that's like machine learning, another machine learning application, right? So the sounds are collected in a massive amount, and it needs to recognize the gunshot from other sounds, right? And then when the gunshot is detected by triangulation, a signal goes to 911 or the police department, and then they can look at also smart street lights come into play in this too, right? They have cameras, and probably the lights can light up to help police or the other crews in the scene, and they can check actually before they go what's going on actually. So New York City has a lot going on. This is probably old, but I thought it gives another dimension. So this Sensible City is a lab in MIT. So they had a project looking at covering the whole New York City and its whole population, 8.5 million population. They mapped the movements of several million people. Of course, it's not the whole population, but the ones with the GPS data or cell phone data. And they intersected this data with neighborhood air pollution information. Oh, sorry. And then this juxtaposed data gave the New Yorkers which areas are high exposure for air pollution, and it informs public health and policy. So another example, as I mentioned, is the Singapore digital twin. This is really interesting because the idea is like is the ultimate smart city. Let's say they create a virtual version of the whole Singapore nation with. So if you remember those, in sci-fi movies, you can play with things and change things and so on. So that's kind of what they are trying to do. So it costs so far over 80 million. It's not still complete. but I would suggest you to go check. So one major contribution of this thing is, we collect data from, let's say, Department of Transportation, water resources, and so on. With this, the whole city is connected, tied together, and all these agencies communicate with each other. If one does something or collects something, the other knows what does that mean for them. They can communicate and make decisions and governance together. So I may not, this is not necessary, but this is just to give you a simple example. So we said that smart city has like smart mobility, this and that. So this micromobility is one tiny component of that smart mobility, because it's app-based. All the app-based transportation modes can be considered somewhat smart because we can follow, collect information, and so on. And similarly, it's like smart car. Like, if you use metro or other transportation options using a card, that card collects your information, origin, destination. But of course, as a person, you are not followed. This was actually a study stemmed from a data challenge event and then turned to a paper later on. We collected real-time, or we scraped real-time e-scooter data from different companies operating in DC, Lime, Lyft, and Jump. So, for instance, because we collected the data continuously for several months, we could look at weather impacts, special days, and so on. And we can look at the spatial concentration at different places at different times. And then we could also use pattern recognition to come up with trajectories, which are not typically available from the data you have, but you can infer them. And we made heat maps of significant corridors or trips that are concentrated in different places, like where the most scooter trips are happening. And we also looked at, basically this is to help city to manage these scooter trips. Especially the question was, many of these companies were trying to expand, increase their number, and that before city decides, should I allow them to grow or not, they need to look at what are the safety impacts, what are the crowd impacts, because these are dockless and they were kind of causing piles of unwanted devices, scooters all over the city. Anyway, so this was just a small example, and we looked at also crash-prone areas and how what would be the safety precautions of that. So I'll just few seconds for challenges. As we talked about, big data is difficult to deal with. So some of the still open challenges and problems are data integration from various sources is still a big challenge, especially in the city context, because they are owned by different entities, different companies, and sometimes they don't necessarily want to share their information. Need for processing high volume of data and ownership and sharing, as I said, is very complex. And location of computing is also interesting. Does it need to be at the sensor, at the receiver? And geographic scale is another thing. Like, do you work with the whole city scale, or do you work with the municipality scale, and so on? And ethical concerns. All this technology sounds good, but they need to be meeting some need, right? They need to work for people, or they need to be human-centered and community-based. If a technology might be so great, so advanced, but if the people don't necessarily show interest or need that, if the public doesn't have buy-in, then that technology probably is not going to succeed. And privacy issues, especially with the location-based data, is a big challenge. And data can be misused, right? And we see examples in healthcare, and criminal behavior prediction and so on. And also, it's not only about cities, right? There are rural areas too that needs this technology that improve their lives. So when we say cities, we cannot just say like smart cities and rural areas, but that's a term, but we are not excluding rural areas too. And yeah, that's about it. Thank you.